we're back again.
And we're back
You were
again
too fast
with
the first time.
mathematics with Miss Meyer in the Learning Institution of Meyer.
Let's go. All right, now you just wasted 20 seconds there. Let's move on. Okay, this is also u-substitution. Why is this different? Okay, so you got an extra seventh inside the sign. Can we do the derivative or reverse derivative rules? Normally we would have said if you integrate a sign, you get a what? You get a negative cosine. Oh, can I do that if I've got an x to the seventh in it? No. Our integration and derivative rules only worked assuming you had an x in there. When we did derivatives, if you had x to the seventh in there, you would have had to chain rule it. So this is the same way. You cannot have a quantity inside the sign. So therefore, this time, what do I want to use substitute?
You want to use substitute?
I want to just the x to the seventh, because sign is okay. We don't have to do sign. I just want to do the x to the seventh. So therefore, I'll leave the x to the sixth. I'll have sine of u, and then I need to substitute in for the x, which is going to be fairly easy, because the derivative will be 7x to the sixth when I don't smear it, and therefore I'm going to have du over 7x to the sixth. Is that good news?
Yes.
Yeah. My x to the sixths are going to cancel. You think? What do you do with the 7? Okay, so now you are technically just doing 1/7 times the integration of the sine of u. And we know integration of sine of u is really cosine of u. And since we got a we should put a, so it's a negative 1/7 cosine of u. Is that my answer? Circle it.
No.
You got to put u back in. So yes, it's negative 1/7 cosine of x to the 7th plus c. So what tends to make the trig functions a little tricky is you having to decide, do I substitute for the whole trig function like we did here in the first one with the tangent, or do I substitute for that's called the argument, what's inside a trig function, what's inside any function is the argument. So in this case, we substitute for the argument. So
Next problem.
let me make that decision a little bit more difficult. Oh yeah.
Is this page 5?
This is page 4.
Actually, I want to be in the spring club.
Okay,
All right. So you have two trig functions. They have 1 over y's inside of them. What do you substitute for?
1 over y.
Okay. We all think 1 over y?
No.
1 over y squared.
I agree, but I feel like you don't.
I feel like we should do it for...
Will it be okay to have two trig functions left?
No. 1 over
It'll end up being secant.
It'll end up being a secant tangent. Is that okay?
Yeah.
Yeah, because we have a rule for secant tangent. That's what I mean by you've got to think ahead. If I substitute for this, what will I be left with? Will this work or not?
That's all I'm telling us, man.
So yes, you are correct. Now, the problem I have with this one is we do the derivative wrong. How do you do the derivative of 1 over y? That's the integration of it.
1 over y squared.
That's y to the negative first. Yeah, there we go. It'd be negative 1, y to the negative 2, which you would drop to the bottom. So it's actually, yes, negative 1 over y squared dy.
I just missed the negative, otherwise besides that, okay.
So when I move it over to the other side,
y squared, so it's going to be negative y squared.
yeah, the y squared will move to the top. I will have negative y squared times, it's supposed to be a du. And then over here, Do I leave this 1 over y squared that was up front?
Yeah.
Yes, it is.
I feel like this one was planned out too, Ms. Meyer.
And that would be secant of what? Yes. Secant u, tangent of u, and then negative y squared times du.
Hey guys, look, the white chairs cancel out.
Imagine that. Nothing is pre-set up, Dylan. It's all magic.
Who's with the negative though?
What do I do with the negative?
Negative secant tangent.
Just throw it out front. So technically, you're integrating a negative secant of u, tangent of u. And golly gee, is that a rule we know?
That is secant.
It is indeed. Going backward, that would be just a negative secant of u.
Oh, look, there's a negative, we have a negative out front.
And am I done?
No. Negative, but you.
I gotta put the u back in. So I would have a negative secant of 1 over y plus c. And actually, if you think about this one, if you think about taking the derivative of this one, derivative of secant would be a secant 1 over y, tangent 1 over y. Then you'd have to chain rule it, do the derivative inside, which would give you the 1 over y squared.
So, what page are we on now?
It makes sense. We are on page 5 of 5.
Thanks to Dylan's smart math.
Why
skills
my
here.
board says I'm already on 5 of 5 means I've got an extra page somewhere.
Find it. Find it. Waste time.
Oh, there it is.
Math class is not fair, guys.
Okay. All right. Now here's something with a little pizzazz to it.
Smart, I don't like your says.
What am I going to do with that mess? I actually have
Yeah, that's you.
the 4x minus 7.
No, the sign of
You pull out the 4x minus 7.
the whole bottom.
Okay, so I'm hearing two choices. I'm hearing 4x minus 7, or, Jill, you're saying sine of 4x minus 7? Am I understanding you correct?
I think that's it.
Well, I'm sorry.
No one know anything.
Why does Jill gotta be your
But then
eye?
you could do cosine.
What's that, Jill? I'm just writing down what I heard.
Let's do 4x minus 7.
I think
Okay,
it's
here's where I want you to think ahead.
But then when you.
If you do that, you'll have cosine of u over sine to the 6th of u.
And isn't cosine and sine
Can you? Well, cosine over sine is cotangent, but this sine is a 6, that cosine is only 1.
Taking out sine to the 6. Take sine to the 6, 4x
And can
minus
you,
7 out.
will you be able to do an integration of a cosine over a sine to the 6th?
Nope, that's
Yeah,
not possible.
that's not going to work.
So taking out sine to the 6.
So then,
4x
okay,
minus
let's process the second one. Maybe Jill's not right either.
still isn't.
7.
If I
Sine to the 6.
if I do that, if I do sine of 4x minus 7, that will give me a
U to the 6.
u to the 6th on the bottom, which would be fine. Okay, think the derivative. What's going to be the derivative of that? It's going to be the derivative of sine is going to be the cosine of 4x minus 7. And the cosines will cancel, yes.
Oh, wow. Good job,
So
Jill.
yes, Jill is correct. And we
Jill,
should
you
do the
gave us
second one.
video. Yes.
And y'all just, now, there's another little error that will cost you a half point or point right here for forgetting something.
But no, it wasn't.
There's something else that has to be done here. Y times 4. You must do the chain rule. And yes, and I would need my dx then. So when I solve it, I'm going to pull that 4 in front of the cosine and write it as 4 times the cosine of 4x minus 7.
Wow, this is a lot of ads, Meyer.
It is. So am I changing this cosine or is it staying here? It is staying here, because we hope it's going to cancel here momentarily.
No, it's going to. We already decided.
The bottom's going to be u to the 6th.
Hey, look, the 8 and 4 also kind of cancels too.
That's correct. The 8 and 4 will reduce. So I am canceling the entire cosine of 4x minus 7 with that entire cosine of 4x minus 7. And then what else did Ashley want to cancel? The 4 goes into
Okay.
8
We gotta delete that.
2 times. Alright, so we would indeed have left a simple 2u to the negative 6. How pretty is that?
That's pretty.
Very pretty. And so if I add 1 to the power and divide by the power, now it's easy. 2u to the negative 5 over negative 5 plus c, which would then, I need to rearrange here. I need to put the u in, and where do we need to put the u? I need to go to the bottom. So I'm actually going to move the negative to the top. I've got negative 2, 5, and then the u was, okay, I have to put the 5th power on the sign.
Sine by the
Yes, sine to the 5th of 4x minus 7.
What's the plus C?
And plus c. Isn't it? But I hate to tell you this. I need to look. I have this terrible feeling this just doesn't seem like enough. So, a brief pause while I check my notes.
What? No.
We're done.
We're done. So you guys need to have a good day and get better. Wow. Such a nice guy. See, everyone had the passion and niceness of Dylan.
Hope you all get back soon.
We miss you.